Hello. In this video, we are going to explore finding the line of best fit by eye, estimating the line of best fit, and then using it to answer questions. So we have this example down here. On a hot day, 6 cars were left in the sun in a car park. The length of time each car was left in the sun was recorded, as well as the temperature inside the car at the end of the period. So you can see there were 6 cars. They were left a varying amount of time from 5 minutes to 50 minutes. And then we also measured the corresponding temperature inside the car for that information. So the first thing they ask us to do is to calculate X bar and Y bar. Recall those are the means or the averages. So you would take all of the X values, add them together, and then divide by 6, and you get 30. Take all of the Y values, add them together, and divide by 6, and you get 38. So that's our X bar, Y bar. Second thing we're going to do is we are going to draw a scatter diagram for the data. So below, I labeled the x-axis time in minutes, and I labeled the y-axis temperature. I figured out that the time ranged from about 0 to 50 minutes, so I counted from 0 to 50 originally. But then I also read ahead in the question and realized I'm going to need some more information, so I made my graph much larger. Secondly, for temperature, the temperature is about 20 to 50, and I counted along my y-axis. So I started plotting my points. So I went to like 50 and plotted 47. I went to 5 and plotted 28. I went to 25 and plotted 36, etc. So these dots here are my 6 dots. I then also plotted my mean point. So 30, 38, that was here. After I did that, I took a straight edge, although not very straight. It should have been a straight edge. And I put it on this value, on my mean point, and I angled my straight edge up and down until it sort of looks like it spread the data, or split the data. So I have about 3 below the data, about 3 above the data. This measure is pretty far away. This point is pretty far away. So I'm just trying to like put a line through our average value that sort of splits the data evenly. This is why it's called a line of best fit by eye, because you are just eyeballing it. Once I have that, I draw my line. So then it asks me, part D, predict the temperature of the car which has been left in the sun for 35 minutes. So using my graph, I'm going to find 35 minutes. This is 20, 30, 35 here. And I trace up and I find this value up here. So it looks to be about 25, 30, 35. It looks to be about here-ish, which I'd say is just shy of 40, maybe at 39. So I said 39 degrees is the temperature of the car which has been left in the sun for 35 minutes. Then they asked me to predict how long it would take for the car's temperature to reach 55 degrees. So now I am over here at 55 degrees here on my y-axis. And I'm going to draw that across until it hits my line of best fit, and then go down to my x-axis until it hits the time. And it looks to be about, in this graph, it looks to be about 130 minutes. I don't know why I said that. That must have been for a different line of best fit. So 130 minutes. Your graph would give a different answer than my graph because your line of best fit by eye would be different than mine. If two students happen to have the identical same answers, that would be very suspicious because there's really no way that your line could match somebody else's line. All right, last part, comment on the reliability of the predictions in D and E. So D, which is predict the temperature of the car which has been left in the sun for 35 minutes. We went to 35 minutes and we predicted it. That is a reliable prediction because it falls within our measured data. There. For part E, where we predicted how long it would take for the car's temperature to reach 55, that point was way out here. That is a not reliable prediction because it's too far away from all of our data. So if we're making predictions, our predictions need to be relatively close to our data for our line of best fit to fit. As we get further away from our data, our reliability of our line of best fit is less and less accurate. All right, the reason why is interpolation and extrapolation. So in order to make that distinction, we identify the lowest data point, so the smallest on the x-axis, and the highest data point, which would be the one that is furthest away. Those are considered our lower pole and our upper pole. And our any predictions that we make that are in between those values within our data set, that's an interpolation. Any predictions that we make outside of those, down here or up here, those would be extrapolation. So when estimating a value that falls between the poles, you are interpolating. So inter means between. And when you are estimated data that falls outside of the poles, you are extrapolating. Extra means on the outside. So the accuracy of your interpolation depends on the strength of R. So you would calculate your R value as to whether or not you could really rely on your interpolation. And the accuracy of your extrapolation depends on the strength of the model and the assumption that you have a linear trend. Not all trends are going to be linear. They might look linear at a small location, but as you get further away, they are something else. Okay, that's it.